Hello everyone, welcome back to my channel, and today is day 21 of our 100 days of DevOps journey. So we're going to continue the way we've done in the previous days. We are still in the phase 1. Today is actually the last day of the phase 1 of our 100 days of DevOps journey. So if you've not been following from the day 1, so what we've covered so far is we're trying to cover the core foundations. We've covered Linux, we've covered writing bash script, we've covered networking concepts, we've covered version control, where we looked at Git and GitHub, and we just rounded up on our session on YAML. So today is going to be the last day of the phase 1 of our 100 days of DevOps journey. And if you're seeing this channel for the first time, basically what we do in this channel is we cover everything DevOps, we cover everything cloud and tech in general. So if it is something that resonates with you and something that you would like to be a part of, feel free to like my videos, subscribe to my channel, and most importantly, don't forget to turn on your notification bell. So whenever I post new content, you're going to get notified immediately so you can watch it and then you can add to your knowledge. So today was originally supposed to be used for Python, but I discovered that Python would take actually more than 1 day to actually cover it, because we don't just want to do surface level studies. We want to be able to dive deep, understand why things are the way they are, understand the things that happens under the hood. So I decided to um, replace that with an equally highly important thing that as a DevOps engineer, as a cloud engineer, you're supposed to be able to work with. And what I replaced it with is something that we work with almost every day. And that thing is what I call NGINX. So if you're hearing NGINX for the first time, or if you've been hearing NGINX for a while but don't really understand how NGINX works, I can guarantee you that at the end of this video you'll have a very good idea of everything about NGINX and even how to work with NGINX. So you will discover that NGINX is very easy to configure, easy to work with. So without wasting much time, this is actually going to be hands-on. I'm not going to be just showing slides or talking too much without showing practical. You are going to practicalize everything on this particular session, and it's really going to be interactive. And that's why I said by the end of this video, you would have a good knowledge of how to work with Nginx by yourself. So what is Nginx? So Nginx is a web server, or Nginx was um, originally pro, originally set up to be an open source web server. But before that, let's understand what a web server is. So in our class on, or in my video on understanding OSI model and TCP/IP, I explained that the way data flows from level 7 down to level 1, which is from the application layer to the physical layer. So you send an HTTP request from the layer 7, and then it goes through all the layers and it hits the layer 1, and then layer 1, the server that is on layer 1 receives the request and sends the request back to um, you that make the request. You understand? Since, for example, you're trying to access facebook.com. When you type facebook.com on your browser, all these things happen. It goes from layer 7 to layer 1 and layer 1 back to layer 7. So now the question arises, okay, what actually serves that content from, that is the content in the layer 1, that's the server on the layer 1, the content in the layer 1, what actually serves that content up to your layer 7, which is the application layer. So, and that's where the web server comes in. So basically a web server is a software or a computer that delivers web pages to users over the internet. So basically your facebook.com, your amazon.com, your google.com, those pages are all served by what we call web servers. So it essentially stores, processes, and delivers web content such as HTML files, images, videos, in response to requests from the web browser. So like I said, whatever you're viewing on your web browser, what actually shows you those content is actually your web servers. So it is highly important for you to be able to understand at least one web server, because as a DevOps engineer or as a cloud engineer, you will be working with web servers from time to time. So, and the preference now is NGINX, because NGINX is not actually the only web server. We have other web servers, like you can see on my slide here. The two of the prominent ones are Apache, which is the HTTPD server, and then NGINX. So we have two major ones, like I said, Apache and NGINX. So we're doing a comparison for why NGINX is better than Apache. So now, when we talk about Apache HTTP, that is just predominantly a web server. It doesn't really do so much other things. It is designed to be a web server. But NGINX has numerous functionality that puts it way ahead of any other web server, because apart from being a web server, yes, NGINX was originally designed to be a web server, but with time, improvements were made to it. Apart from being a web server, NGINX can serve as a reverse proxy. NGINX can serve as a load balancer. NGINX can serve as a cache. So many other things. You can even implement security, because NGINX comes with some default securities, and the benefits are just so much that you cannot even overlook it. So apart from that, NGINX, in terms of speed, NGINX is way faster. It can serve contents to you very, very, very much faster than other web servers. So a lot of other benefits of NGINX over other web servers puts it ahead of other web servers in terms of choices. When people want to make choices of the web server to use, most times they go for NGINX. And NGINX is really, really very easy to actually set up. There's nothing complex about it. You're going to see that once we start our hands-on demo on our VM. So yes, now we understand what a web server is. It's nothing complex. It's basically what just serves content, delivers your web pages to you when you make a request to it. It's as simple as that. So now let's look at NGINX. Let's focus on NGINX for DevOps, because that's what we are here to do today. Like I said, NGINX is an open source high performance website. So apart from being a web server, NGINX can also act as a reverse proxy, a load balancer, HTTP cache, mail proxy. So we are going to look at these things one after the other. So by the end of this session, you will understand what NGINX is and why it is important in DevOps. You will learn how the request flows from NGINX, the worker processes, and all of that. Then we are going to start our hands-on, where we'll install and configure NGINX to serve a real web page, a static web page. We are going to configure NGINX as a reverse proxy for a Node.js app. We're also going to implement load balancing. We use NGINX as a load balancer for about 2 to 3 upstream servers. Then we are going to configure security in NGINX, which is your SSL and TSL. So basically, this is what we are going to cover today. We are covering NGINX under 4 different categories. We are going to set up a static web. We are going to host a static website using NGINX, which is using NGINX as a web server. We are going to use NGINX as a reverse proxy, where I would explain what a proxy is, reverse proxy, and all of that, and how we use NGINX to do that. And then we'll also do load balancing. I will explain what load balancing is, and then we'll go to the terminal. We configure NGINX as a load balancer, and then we'll also implement security into our NGINX. So let's go straight to our terminal without wasting much time. So I'm on my terminal now, and the first thing is we are going to check if NGINX is actually running. So we do sudo systemctl status NGINX. So it's asking for my password, and I'll do that. So I have NGINX installed on my setup on my VM. So it's active and it is running. So but for example, if you don't have it, so they are just basically, it's just 2 steps to install NGINX on your Linux VM. The first is update your repository. So you do sudo apt update to update your repository. So it's going to just update. Basically, we do that whenever you want to install a new package. It's always advisable for you to update your repository first, so that every day they are working on all of these packages. So new releases, new patches, new versions, and all of that comes out from time to time. So it's better for you to keep your repository up to date, because there are some applications that whenever you want to use them, you need to have the latest version of some libraries, some packages, and all of that. So it's very, very important for you to always update your repository before you install a new package. So now that we've done that, so to install NGINX, so basically it's just sudo apt install nginx -y. So basically, sudo apt install nginx -y. It's as simple as that. So I'm not going to run this because I already have nginx installed on my system. So this -y that I put there, if you run it without using -y, it's going to get to a point where it will ask you a question, yes or no. So usually you just type y, which is yes. So if you don't want to do that, you just use the -y to automatically, what it does is that -y automatically says yes to all of the questions that you could possibly be asked when trying to install a package. So now that that's out of the way, you can see that it is very, very easy to install NGINX on your Linux VM. So now that NGINX is installed on our VM, we need to start working with it. So the first thing we'll do is we'll have to understand NGINX architecture, or how it works. So now, once you install NGINX on your VM, on your Ubuntu VM, a file is created, an automatic file is created in a directory called /etc. So when we go to /etc and I do ls, you will see that you can see nginx here. So a folder is created, which is nginx. So by the time we cd into nginx and let me do ls-l. So this is all the folders that is in your nginx. So this folder basically contains everything that nginx works with. This is like whenever you want to configure anything on nginx, this is where you should always go, /etc/nginx. So then you can modify whatever you want to modify. And I'm going to basically talk about just three major parts of. I won't be going through all of this. I'm just going to point just three things, and three things I'm going to point out is your nginx.conf, your sites available, and your sites enabled. So for nginx.conf, this is basically like this is the brain box of nginx. So this is like where the admin comes to configure. You wouldn't be coming here all of the time. Some people come to nginx.com to do their basic configurations and all of that, but I don't really think it is ideal. It will work, of course, it will work definitely, but if you're using nginx at a server level, most times you don't go to the nginx.com to tamper with things. But let's say, for example, you're working with containers like Docker and all of the rest, where you are allowed to configure your nginx, personally. Then you can always create that one. You will have to create an nginx.com file by yourself and then put all of the inputs inside. But this particular one that is created by nginx itself, hosted on your server, you don't really tamper with your nginx.com, because that's where administrative configurations, go into. Now, sites available, basically it's where you now configure your personal servers. Let's say, for example, you want to, if I do cd sites available, so when I do ls, when you see default is this is where you configure your default web page. This is where nginx will always go to when it wants to serve a web page. So but if you now have, let's say you want to serve another web page, or you want to create another web page, you can go here. You can now create different let's say, for example, like Amazon. Now Amazon will come here and create amazon.com, amazon.ca, amazon.co.uk. So everything will be created here. So by the time they want to serve their websites, it comes to this place. It's always coming to sites available to come and check Whatever configuration is here, whatever that has been stated here is what it will serve to the customers or anybody that requests for those particular websites. So basically, this is basically where you put your own configurations of your web servers. So now, site enabled. After making your configurations in sites available, you need to link it to site enabled. Whatever is not linked to site enabled will not engineers will not enable that configuration. Basically, it's as simple as it is. So it's not enough for you to configure your web server in sites available. You have to link it to site enabled. Let me prove that to you. So now when we seed it into sites available, you can see that we had one file here which is called default. Let's go back a bit. Let's seed it into sites enabled. If I do ls, you'll see default. You'll see that we have default here, we have default here. Let me do ls-l. So this will give a broader detail of what it is. So you can see that the name is default. You can see that it has an L in front. L means is a linked file, and you can see the folder it is linked to sites available / default. So whatever changes you make in, or whatever you do in if you make a change in this default folder, it automatically makes a change here because it is linked. So but if you're creating a new file itself, you have to link it to site enabled so that NGINX can actually enable that site. If not, you're just going to hit blockers. So this is one of the issues. This is one of the troubleshooting issues that you might face. You just quickly go to sites available, you create your website, you do everything, and then you're trying to reach that web server and it's not going through. And you keep wondering what happened. So you need to make sure that it is properly linked to site enabled. If it is not linked, there's going to be an issue. I'm taking my time to re-emphasize on this so that we're able to absorb it. We're able to understand the importance of linking these two files together, sites available and site enabled. They always have to have the same files linked for NGINX to be able to work. Now, if you make your configuration in nginx.conf, you don't even have to bother about what is in sites available and site enabled, because this is like the master configuration. That's why some people actually go and configure their stuffs on nginx.conf and then just go from there. So let's cut nginx.conf and see what is there. Okay, sorry. Let's cd cut nginx.conf. So I'm going to take a moment to explain this configuration for you. But before I start doing that, there's something I really want to say, and you need to understand this well. So basically, the whole architecture of the way I explained the importance of YAML, or the building blocks of YAML, NGINX also has its own building blocks. So basically, NGINX works with context and directives. Those are the two things NGINX works with. If you check your NGINX configuration, however it wants to look like, they are basically context and directives. So this is something that you should know. NGINX works basically with context and directives. Now, I'll start with directives. So what is a directive? Directive is the actual instruction or command that you've given to NGINX to execute. For example, this for here now we have user www-data, which is of course the user that runs the NGINX process. You can see worker-processes, you can see auto and all of that. Now all of these are called directives. This PID, error log, basically these key value pairs are called directive. This send file on worker connection 768, they are all called directives. So they are like commands. It's like saying make the worker connections to be 768. I'm going to explain all of this later. I'm just trying to explain that NGINX works with basically get directives and context. So all of these are called directives. All of these ones include default type and SSL protocols, SSL preferred server. They are all called directives. Now, what is a context? A context is a group of related directives that comes together to act or to work on a particular configuration. Now, this HTTP block is a context because you can see that it has several directives. You can see that it has several directives in just one block. So this block is called a context. Event is a context because you can be able to add other things. You can see that there's another directive here, even though it is commented out. You can see that there's another directive, and you can see that it is different from all of these ones. All these ones are not placed in blocks because they are just directives. They are not placed in context because they are individuals. They are not working together to achieve one thing. So the event block is a context. HTTP block is a context. This mail block is a context because they are it contains groups of directives that comes together to work on a particular part of your NGINX configuration. So I really hope that is clear. NGINX basically works with context and directives. Directives are the main commands that you give to NGINX. Why context is a group of command. Basically, it's just block of commands. So, and I've already showed us what a directive is and what a context is. So with that understanding, I can explain some other parts of this particular configuration. So yes, like I said, the user www-data is a user that NGINX of course created to run all this service. Now, what are worker processes? Basically, worker processes, it controls how many processes NGINX spawns to handle client requests. Basically, it's just like when you have workers, how many workers will handle a particular request. So that is what worker processes are. So sometimes you can see that worker processes, you can see it has auto here. Sometimes you will see one, sometimes you will see two, sometimes you will see, most times you will see auto. What does this mean? If you see a worker process and you see that it is one, that means it is using just one worker process. You are assigning just one worker. And when I mean what in this context, what we mean by one worker is one CPU, one CPU core. Let's say, for example, now you are using a VM that has 4 CPUs. If you assign your worker process as one, it's only going to use one CPU to process traffic coming into your web server. And definitely you should understand that the higher the worker processes, the faster you can respond to clients. So now it is advisable that your number of worker processes is equivalent to your number of CPUs. So if you have 2 CPUs, your worker processes is supposed to be 2. If you have 4 CPUs, your worker process is supposed to be 4. If you have 8 CPUs, just like that. So what most people do is that most people use auto. Auto means that you're giving NGINX the liberty to, by itself, determine how many worker processes it's going to use. And most times, NGINX will always use the same number of CPUs that your machine is running on. So basically, those are what worker processes are. So that's what it is. And then PID is just basically the process ID. This is where you can find the process ID of NGINX. So if you want any error log, if you're running into errors and you want to check the logs, you can see it in slash this and this and this and all of that. So now let's go to I don't need to explain what event is. It's just a block of code. It's a context. Now let's go to worker connection. So now we've already established that worker processes are like the number of workers that is used to handle requests. So now worker connections, now it determines how many connections each worker can handle simultaneously. So that per worker process that you have. If you have one worker process, if you have three worker process, per one worker process, how many connections can each worker process handle simultaneously? That's what worker connection says. And the default that came with this configuration is 768. So you can increase the number, you can decrease the number. So you can see that only just one worker process can handle 768 connections at the same time, and that shows you that in turn explains why NGINX is fast. So you can increase it. I can increase it to 1024, but you should note that the higher the number of the worker connection, the faster the process, but then the higher the memory usage. So everything is a trade-off. You're trading off speed for memory usage. So the higher the number, the faster it can process requests, but it uses more memory. So that is just basically the trade-off in this particular scenario. So I hope you understand what worker processes are and what worker connections are. So we'll move to the HTTP block. Basically, HTTP block defines how NGINX should handle requests for a particular domain or IP addresses. So per domain or per IP address. This block defines how NGINX will handle requests. So just basically defines how it listens for connection, which domain or subdomain the configuration applies to, and how to route the request. So anything that has to do with a particular domain or IP address, all the configurations go into the HTTP block. So that's I'm not going to start going through all of this one after the other. This is what I feel like we should understand in this particular um, file. So yeah, this is everything about the nginx.conf. So we are going to go to sites available where we would configure a website or a web server. Now, I forgot to mention something. The default port for NGINX is port 80. So now, since we have our NGINX running, let's do something. This is another way to confirm. I should have said this earlier. It skipped my mind, but I just remembered it now. So there's a way to confirm that your NGINX is working. So if I do, let me get my IP address. Hostname -i. So this is my IP address 192.168.199.136. So if I try to reach this IP address on my local browser, so let me paste this. So let me see. Port 80. I'm supposed to be able to. I think I got where the issue is. I was using HTTP instead of HTTP. I was using HTTPS instead of HTTP. Yes, so I was using HTTPS instead of HTTP, which we've not configured HTTPS. We've only configured HTTP. So this is a way to configure or to confirm that your NGINX is actually working. You will see welcome to NGINX. If you're seeing this page, the NGINX website is successfully installed and working. So this is another way to confirm that NGINX is actually working perfectly. So yes, you're going to do that. NGINX works on port 80. It uses HTTP, which is on port 80, and then HTTPS is on port 443. And that's why before now I took my time to explain ports, because everything that we do, like I said, I always say it in my video, whatever we do is layered on what we've learned previously. So we are not just learning things in a scattered manner. Everything has been arranged systematically in a way that you have to learn one thing before you can learn another thing, so that when you learn the second thing, you just make reference to the first thing that you learned and it doesn't become new. So yes, you need to understand ports and all of that. So port 80 or 8080, and then port 443. So now that we have that out of the way, I just needed to mention that. So our NGINX is up and running, and then we have this web page already, working fine. So we're going to go back to our terminal. Let's do ls, and let's cd to sites available. So you might be wondering, where did NGINX see this particular content that it is serving? So if I do ls and I do cat default, so if you come down here, we'll see we have a server block here. You can see that, like I said, everything is just based on directives and context. So we have a server block which shows that it's telling NGINX to listen on port 80. So this, you just give it a name, default server. It could be localhost or anything. So listing on port 80, listing on your host IP address on port 80 also. So then you come to root. Root is /var/www/html. What this means is that where this particular content, where am I serving it from? Where is it located? If I want to go and check this particular content, where can I find it? So it is located in /v/var/www/html. That is the folder it is located. Now you see index. Index means which particular file is this content in. So it now gives you a variety to say, okay, check index.html. If there's an index.html file there, you serve that one first. If you don't find that, look for index.htm. If you don't find that, look for index.nginx-debian.html. So it looks for these three folders, because that's basically just how you set it. You can configure, like I said, NGINX is very, very easy to configure. You can configure it to do anything. We are going to do that right on this particular video. You'll see how dynamic NGINX can be. So you look for all of this. If you find any of this folder, the content in that folder, you serve it to the web, basically. And then location means that when, for example, if you come here and say, you can say http 192.168.36. I believe that you've seen some website that you have, like you had a slash something. You can say slash videos. Then when you do slash videos, it directs you to a different web page. So basically, it's what you're trying to say. Now, if you don't add anything to the back of this, there's an automatic slash at the end, which shows that this is just the root. This is the root folder or the root file. So there's an automatic slash at the end of this IP address, which you can omit. If you omit it, it's fine. If you don't omit it, like now, when I did this one, I didn't put the slash, but when I'm doing this one now, I'll put the slash, and you'll see that it will serve you the same thing. So there's an automatic slash just at the back. So that is what location is. You can define your location to be anything. Just make sure that it's what is inside the block. So now what is it saying? Look for all the files. Look for the URI slash. Look for the URI. That's the one that I typed, the IP address I typed without the slash, and then the URI with the slash. If you don't find the two, throw a 404 error. A 404 error. And a 404 error means that thing that you're looking for does not exist. So if you need to understand error codes and all of that, you need to understand what a 200 code means. You need to understand what a 301 code means. You need to understand what a 404 means. You need to understand what a 502 means. So anything that has to do with 404 or 40 something, the issue is you are looking for the wrong thing. What you are looking for does not exist. That means the issue is from your own end. That's what basically a 404 error means. So now if you don't understand or if you don't know what it means before now, I've told you a 404 error basically means that what you're looking for does not exist. That means you're looking for the wrong thing. Kindly type the right thing and I will give you what you want. That's basically what the system is telling you. When you see a 504 or 502, basically the issue is not from your end, the issue is from the server end. The server you're trying to access is not reachable. So and all of that, it's actually so deep. We're not going into error codes in this particular video, but just say let me just chip that in. So basically this is all the configuration you need. You can see that every other thing is commented out. It's as simple as that. So what we're going to do is that we're going to delete all of this and we are going to configure our NGINX to serve a static web page from scratch. So let me vim that. You'll see how easy it is. Let me clear sudo vim. Okay, I said where you can locate the file is, let's go there, cd / var. You'll see that that folder actually exists. So in our, remember we said the root was /var/www/html. So when you do ls, when I do ls, you can see that I have index.nginx-debian.html. And when I cut this, you can see welcome to NGINX. If you are seeing this page, it means blah 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 and all of that. And you can see that it's definitely the same thing with what is here. So it's just straightforward. Just point NGINX to a folder where your index.html file is. It's as simple as that. No much issues, no complications and all of that. So let's go back. So I have a static web page that we are going to be configuring. We are going to be setting up sites available. So there's sudo vim default. Okay, so I'm just going to delete all of this down to this place. I want to delete everything that is commented out. So we're going to set it up by ourselves. I'm just going to delete everything basically. Let me start from here. So I'll leave the server block. Okay. Okay, let me just do this. Let me delete this one too. Okay, I'm going to uncomment all of this. And we're just going to do a minimal setup. Great. So I want NGINX to, I'm going to serve a web page now. I want NGINX to listen on port 8080 and I would change this. I'll give it a server name. I'll delete this and so server name, I'll change this to localhost. The root will be the same root. I'm going to show you that regardless of the root you specify, NGINX will serve as long as you've specified where the root file is or where the root folder is. NGINX would go there and get that particular web page from you. So we're going to have index.html. So this is very, very basic. Listen on port 8080. The server name is localhost. Which folder can I find this particular index.html file? So it's var/www/html. And which folder are we actually looking for? We are looking for, you remember the previous one, we specified about 3 to 4 folders that you can check. But now we are looking for index.html. So I'm going to save this configuration. Whenever you configure or whenever you make changes to configuration in NGINX, then you should always check if your syntax is correct. So, and the way you check that is you use sudo nginx-t. So once you type that, you will see syntax is okay. So you should always, because it helps a lot. Because sometimes I've been in situations where you make a single error as little as a comma is, it can actually mess up your code. It can mess up your configuration. So it's always good to confirm that your configuration is okay before you run it. That's one. Secondly, you always have to reload your configuration. If not, it will still be using the old configuration to work. So, and how do you do that? You can do sudo systemctl reload nginx. So once you do that, nginx has reloaded, and you can restart. Now, if I go to this particular my browser and I refresh this page, it will throw me a 403 forbidden error. Basically, I told you anything that has to do with that starts with 400, it means that that web page you are looking for does not exist. And if you can take a wild guess why it does not exist, why do you think it does not exist? If I do cat default, you can see that I have specified that I only wanted to check index.html in /var/www/html. Now, if we go to this particular folder and I do ls, you can see that there is no index.html file in this particular folder. So that's the folder I'm looking for does not exist. It doesn't exist. So I'm not going to delete this. I will create a new index.html file and we'll refresh and see if that works. So let me go to my configuration, and I have this web page. So let me create index.html. So I have it here. I'm just going to paste and I'll save. And after doing that, let me reload nginx, and I'll restart nginx. So now we've specified, so now we have index.html here, and we specified that this is what it is supposed to look for. It should not look for any other thing. Now let's go back to our IP address and refresh the page. Voila. Now we have our web page. It's a service status web page. So you can see that it's something that is very, very easy to configure. It's easy to configure. It's not a big deal. It's not a rocket science. Just make sure that you just specify, you tell Nginx, where is the web page that you want me to serve? Where is it located? That's what you put as your root. What is the name of the file that you want me to serve? That's what you put in your index. And then what port are you wanted to listen on? What is your server name? Just basically, these are just about 5 configurations. What port you wanting to listen to, what is the name of your server, where is the folder that your web page is located, what is the name you've given to your web page, and then your location. Which location can people access this web page from? It's as simple as that. Configuring Nginx as a web server, it's very simple. In fact, working with Nginx as a whole is actually very simple. So I'm going to move to the next thing, which is to configure Nginx as a proxy, as a reverse proxy. So before that, I'm just going to illustrate what a reverse proxy is. Most times when you try to interact with a website. So let's say this is your web page, and then you are trying to interact with it. You're trying to interact with it, and you want to send traffic from here to here. Most times you don't hit the server directly for security reasons. Whenever you try to access amazon.com or facebook.com and all of that, you don't hit facebook.com's website directly. You hit you What you're actually talking to is a proxy server. Basically, what a proxy means is a proxy is something that stands in the place of another thing. It's just as simple as, okay, this is I'm going to stand in between yourself. I'm going to stand in between you and the server. And basically, there are two types of proxy. There's what we call forward proxy and what we call reverse proxy. As DevOps engineers, basically what we deal with most of the time is reverse proxy, because forward proxy basically protects the client. That's you that is trying to reach a particular website. A forward proxy protects you in the sense that it doesn't show your information and all of that to the clients you're trying to reach. So the reverse proxy does the opposite. The reverse proxy protects the organization like amazon.com, facebook.com. So it stands there to protect, because now if you're talking to, let's say for example now, Amazon's, let's say you have Amazon's web server, and the website the web server runs with the IP address 172.27.0.6 at port 3000. So if you're reaching out to this port directly, it's not secure, because you could have hackers. They could attack your website. They could send DDoS attack. They could break the rate limit. They could hacking, go in and do so many things. So for security reasons, most times most of these organizations use a proxy server, and most times NGINX is being used as that proxy server, because NGINX has a lot of security features that would not allow you to just get access to a server anyhow. So, and that's because of the advanced security features of NGINX. Most of these top guys usually adopts it. So that's basically what a proxy is and a proxy server is. So NGINX stands in between the requester and then the server, just to protect it from um, any activity. So what happens is, when request is sent out from the requester, it hits the proxy server, and then the server checks the nature of the request. If it's a legit request, the server reaches out to the main server and then gets what information you need and sends it back. So Nginx is able to do that because of its complex nature. So most times when you type amazon.com, facebook.com, you're not actually reaching Amazon's main server. You are reaching the proxy server. You're sending a request to the proxy server, not the main server. It is only the proxy server. It is configured in a way that only the proxy server will be able to talk to the main organization's server. So that's basically, I don't know if that was actually brief enough. A proxy, basically, the whole concept of proxy means doing something on someone's behalf. So talk to me, I will talk to the person. Whatever your request is, the person will send it to you through me. So that is basically what Nginx is coming here to do. So, and then basically one of the big ops, or one of the big advantages of this, is it protects your database, it protects your server, your organization from any form of attack, because now people outside are not reaching your server directly, they're just reaching the proxy. So that's basically what Nginx has come to do as a reverse proxy, and we are going to do a demo of how to use NGINX as a reverse proxy. So we are going to use another web page. So now we are going to implement our backend server, and I'll come to my terminal and I will create, let's cd to my home directory, and move. Okay, so I'm going to make a directory, node server, and I'll vim server.js. So this is basically a Node.js server, and I'll paste this server. So basically what it does is that the server listens on port 88, on port 3000, and it displays hello from Node.js backend and all of that, So in order to work with a Node.js server, you have to install some packages. So we're going to do sudo apt install. We're installing two packages. We're installing Node.js and we are installing npm. npm means Node Package Manager. So that's basically what Node.js uses for its backend. So since you already did, usually you're supposed to do sudo apt update. You're supposed to do that first before you run this. But since I already did sudo apt update, I believe that my repository is up to date. So I just went ahead and I ran to install the Node.js and to install npm, and I used -y, so it doesn't ask me a bunch of questions and I have to keep typing why and all of that. So yes, let's wait for our Node.js and our npm to be fully installed, and then we can configure, we can run it and then configure NGINX to serve as a reverse proxy to that particular server. All right, that took a while. So we have our Node.js installed and we have our npm installed. So I'm supposed to have server.js inside node.server. Okay, that's fine. I'm just going to move it. Okay. So now that we have it here, let's run our server, and the command to run it is node and then the name that you've given to your server. So when I run this, it's saying server is running at localhost port 3000. So let's go and check localhost port 3000 if this server is actually up and running. So I can do, this is the 36, and I can do port 3000. So you can see message. Let me increase the font. So you can see it here. Hello from Node.js backend. So it shows the timestamp, it shows the host name that is sent the request, it shows the IP address and all of that. So basically this our backend server is up and running, and we can access it on port 3000. So now, like I said, it's not always, I can't, if this was a production environment, I cannot give out this particular IP address to the general public for them to access it, because they could actually tamper with it. So what we'll do is that we'll configure NGINX to act as a reverse proxy to this backend server. So how are we going to do that? Let's go back to our terminal. So let's stop this. We've confirmed that the server is, our backend is running. So we are still going to go back to where we went before, which is /etc/nginx/sites available. and we're still going to edit our default configuration. So let's do sudo vim default, and we're just going to make some edits. So in this case, since it's acting as a reverse proxy, we need to remove the index block because we're not serving just a web content. So the configuration will be a little bit different. We're also going to remove this because now we're not looking for files. We want to make it serve as a reverse proxy. We're going to leave the listing the same way and the server name the same because we want NGINX to keep listening on port 80. So what it is doing is that we are going to be routing, or we're going to be mapping NGINX default port, which is port 80, to our backend server's port, which is port 3000. So how do we do that? We just introduce something like, we introduce directives. Like I said, directives are the actual command. So we're going to introduce something called proxy pass. So we are proxy pass. So we are passing, or we are telling NGINX stand as a proxy to that particular website. So we'll do HTTP and this, and I'll do 172.127.0.0.1.3. So you might be wondering, where did I get this IP address from? So basically, anywhere you see localhost is equivalent to, this is the IP address of a localhost, 127.0.0.1. If you can Google it, IP address of localhost is 127.0.0.1. I can as well change it. Okay, not to confuse us. Let me just change it to localhost port 3000, so we don't get confused, because when we ran our server.js, we saw that it was running at localhost hyphen 3000. So let's leave it at that. So we can just leave it here, and that will be all. But when I did the illustration of what a proxy means, basically a proxy is, I talk to you, you stand in place of someone else. Whatever I tell you is what you tell the other person. So basically, the backend server is not seeing the original, requester. Where the original request is coming from, the backend server is not seeing it. It's only seeing, or it's only relying on whatever information the proxy server sends to it. However, for login purposes, it's good to have those informations down. So we also want to tell the proxy, okay, apart from just standing in place of routing the request, also make sure that you're telling the backend server exactly where this request is coming from, like the metadata, the IP, the host, and all those information. You want your proxy server to be able to deliver those informations accurately to the backend, and we have a whole bunch of that, but I'm going to be sticking with just two. The first one is to show me the host name. We'll do proxy set header hosts. So it is saved in a variable called host. Basically, this shows the host name of where your request is coming from, because like I said, all this is actually needed for login purpose, because whatever we are doing here is something that they are best practices for a production environment. So I could as well just leave it as proxy pass and then just call it a day. It's still going to work, but we need detailed information to be sent to our backend. Secondly, the backend needs to be very, very sure of where it is to route the request to. So there are just so many things you need to. That's the reason why you need to actually make sure that your proxy is sending the correct information. Because if it was a case where there was no proxy, your requester can always send all of the details to the backend, and the backend gets the entire message. But now that somebody is standing on behalf of the backend, you need to ensure that everything the requester is sending to the proxy is properly forwarded to the backend, so that the backend knows exactly how to act what to do in, take logs and all of that. So the first thing we'll do is to set the host. And then secondly, the backend is not interacting with the IP address of the requester. The backend only sees messages coming from the IP address of the proxy. So we also want to be able to log, or we want to be able to keep track or keep record of the IP address of the requester. And that's why I'm going to add another settings. So this time we're going to set header. We are going to set the real IP address. So we'll do real IP, and it is saved in a variable called remote address. So don't forget to always put your semicolon after you type anything. So basically, this is all that we need. Now it's my NGINX is standing as a proxy. It's mapping port 80 to port 3000. It is sending the name of the host. That's all the metadata that the main requester has, and then it's also sending the real IP address. So it's not just saying the IP address of the proxy server. It's also saying the real IP address of the requester. So this is basically all you need to do. There are so many others. You can, if you Google search, you'll see all the others. So depending on what you want it to, the information you want it to send to your back end, you keep setting and setting. There are a bunch. I think there should be up to 10 of it, but we are trying to keep it as minimal and as simple as possible. So these three is okay: proxy pass, proxy set header host, and proxy set header real IP address. So we'll save our configuration like we always do. We'll confirm that our syntax is okay. Okay, syntax is okay. What we'll do next is we reload our NGINX, and then it's not, you can decide not to restart NGINX, but I just prefer to do it so that I don't have any, just it's better to be safe than sorry. Let me just do everything possible to make sure that this is actually working. If I don't do it, it doesn't harm anything. So when I press enter, so NGINX is starting now. Now let's go, and so now we are not going to be accessing this on port 3000. We would access it on port 80. So let's go and check it. So okay, we have a 502 bad gateway. What does this mean? If you have been following, I told you when you have an error code that starts with 500, it means that you are looking for the right thing, but your backend server is not up. And I did this deliberately. I'm supposed to spin up my backend server before coming back to check this website. So let's go and spin up our backend server. So we'll do cd to our node server. Let me do ls. Let me clear. So we'll do ls. So cd to our node server, and we'll do node server.js. So when we run it, our backend server is up and running now, and we can be reached at localhost 3000. So let's go and refresh. Let's refresh. So voila. So after refreshing, we can see that we're accessing this on port 3000, and this is from port 80. So now we can access our backend server from port 80. So this is just a simple way of handling, or this is just a way of configuring NGINX to stand as a reverse proxy. So we've been able to do two things now, or three things rather. We've explained what NGINX is. We've configured NGINX as a web server, which we use to serve a static content. We've also configured NGINX as a reverse proxy. So I'm going to stop this server now. So we have two more things to go. We're going to configure NGINX as a load balancer. So let's go back to our slide. Now, first off, we need to understand what do we actually call a load balancer. So normally you have various servers. Maybe you have in production environment, more than one server will be used to serve a particular content. Let's say, for example, the Amazon website. Amazon website is not running on just one server. Amazon website is running on various servers, basically for redundancy. And then so traffic is being distributed to different servers. Now, because of the dynamic of this process, we need something to be able to control the flow of traffic, and that is where load balancing comes into play. So basically, NGINX will come and serve as it's just like the same thing. It stands here, and then when a request is made from a client or from a customer, you know, it just distributes the request. It distributes the request. Let's see. Let's make this smaller. And customer comes and it makes a request, and it can redirect the request or to whichever server, depending on how you have configured it. So it can decide that, okay, I'm sending this request to server 1 or to server 2 or to server 3 or to server 4. So basically, NGINX handles that so that one server does not get overwhelmed with requests and crashes. So that's basically what load balancing is all about. It's basically distributing traffic among different servers so that one server does not get overloaded, and all of that. And NGINX works with various load balancing algorithms. Three of the most prominent ones or the most popular ones that we have is, the first is round robin, which is the default load balancing algorithm that NGINX uses. We have list connection, we have IP hash, and so on and so on. There are a number of that. You can Google search to get the other ones and all of that. So what does round robin mean? Round robin means that basically it sends traffic in a sequence. The first traffic goes to server 1, the second traffic goes to server 2, the third goes to server 3, the fourth goes to server 4. When the fifth comes, it goes back to server 1. So basically, that is how round robin works. It goes 1, 2, 3, 4, and back to 1. Then it goes down again and then goes back to 1. That's basically how round robin works, which is the default NGINX algorithm for load balancing. Now, list connection means that, just like its name sounds, it sends traffic to the server with the least workload. Let's say this third server is the one with the least workload, and at the time that a new traffic is sent, it's just going to forward it to the third server. So it doesn't follow that that line of 1, 2, 3, 4. If server 1 is the one with the least connection as at the time that traffic is sent, and then server 4 is the one with the least connection as at the time the next traffic is sent, it's going to go like that. So it doesn't follow a sequence. That's what least connection means. And then IP hash. Now, there's a particular IP addresses that has been configured or pre-configured that once traffic is coming from this particular IP address, send it to this particular server. So it's as simple as, for example, now anybody using ChatGPT, the free version, and then people using ChatGPT Pro and people using ChatGPT Plus, their requests are not sent to the same server. Their requests are not sent. If you're using ChatGPT and then another person is using ChatGPT Pro, your requests are not sent to the same server. So once you register, it's like the system saves your IP address and says, oh, this particular person has subscribed to our Pro plan, and he has been added to the IP address of the special or the VIP IP address, and then whatever privileges that those people in the VIP category enjoy it, you can enjoy it. So basically, it's just mapping an IP address to a particular server. So that's basically what IP hash means. So we are going to, now that we understand the concept of load balancing, the different types of load balancing algorithm, we are going to configure NGINX to start or to serve as a load balancer, and we are going to spin up three servers, three Node.js servers, and we'll see how we can, make NGINX to stand as a load balancer for that. So we are going to do that right now. So it's just going to be a very simple Node.js app. So let's cd, I do ls. So I'm going to make a directory, nginx load. So let's cd into that directory. Then we're going to, let's say, server1.js. Let me vim server1.js, and then I paste this. So basically, this is telling the server to listen on port 3001, and then the response is basically, it will just show response from server 1, and it's an HTTP request. So let's create a second server. So I'll paste this, and then I'll change this to, okay, no, this is wrong. Let me go back and copy this, come back here, I'll paste it here. So it's going to listen on port 3002, and it's going to display request from server 2. So let's create a third server, server3.js, and I'm going to make it server 3003. So to listen on 3003, and the response will be from server 3. So that's that. So now let's test them individually to see that they are all working fine. So let's do node server1.js. So let's wait for that to come up. Okay, so I'm not getting any response. It means that it's working. So let's go to port 3001 and see. Let's see. Port 3001. So you can see response from server 1. So that's good. It means server 1 is working. And let me stop this. Let me run server 2. So let's go and change this to 3002. So you can see response from server 2. And let's confirm the third is working. Okay. And let's go to 3003. So you can see response from server 3. So now we've confirmed that all of our servers are working perfectly fine. Now let's load balance these servers. And how do we do that? We go back to our configuration. Let's see. So okay. So for this, we're just going to add one or two things to this particular configuration. Like I said, NGINX is actually very, very easy to configure. It's not something of a big deal. But I feel that a lot of people, before now, personally, I always felt NGINX was one complex thing. It was very complex to configure and all of that. But taking the time to study and then try my hands on so many demos, so many practicals, I got to understand that NGINX is, I think, one of the easiest things you can actually configure as a DevOps engineer. So we need to just do one thing to this. And what is that? We need to just add a new context, or like we always say, a block. And what is the context we are going to add? We are going to add upstream. Upstream. So upstream basically means that we are whatever we have in this server block is referring to whatever we now put in the upstream. So what name are we going to give it? We can give it node backend. We can give it node backend. Then we create our block, and then in here, what do you put in your upstream block? Basically, you just put the server IP addresses. So we can do 127.0.0.1 port 3001. We do server 127.0.0.1 port 3002. Basically, we just put the IP address of our backend servers .0.1 and port 3003. It's as simple as that. It's as simple as that. So what else do I now do? I forgot something. Don't forget to always put your semicolon, because this can actually mess up a lot of work. You can see that now the color has changed, which shows that I'm doing the right thing. If I saved this file like this and ran sudo nginx-t, it will throw me an error. I'll have to go back and check. So now there's something else you need to change, which is your proxy path. Since we're not running on anything on localhost but we're not running anything on localhost port 30. What we'll do is that instead of referring to localhost, we are going to call the name that we give our upstream, which is node underscore backend. So it's going to be serving contents from all of the servers that is specified under this upstream, which we have named node underscore backend. It's as simple as that. It is as simple as that. There's no need to complicate things further. So let's save this. Let's confirm. Let's confirm. So our syntax is okay. That's good. And then we'll reload systemctl reload nginx, just reload our configuration, and we'll do restart nginx. Okay, so let's see if we'll be able to access those websites. So we'll do http://6.502 bad gateway. We're hitting another error message that says our servers are not up and running. So what we need to do now is just make sure that all of our servers are up and running. So I'm going to run all of these servers in the background. Well, let me duplicate it. Duplicate the tab. Okay. Let me duplicate the tab again. So since we have 3 servers, I'm going to run each server on a different tab. So we'll start with server 1. So cd NGINX load do ls server 1. So we're going to start with server 1, server1.js. So we have that running. Let's go and start server 2, server2.js, and then let's go and start server 3, server3.js. So now we've confirmed all 3 servers are up and running. So, and we understood that the default algorithm is round robin. So what I'm expecting now is for NGINX to be showing me response from server 1, response from server 2, response from server 3, back to server 1. So when I refresh this, good, server 3, supposed to server 2, server 3, server 1, server 2, server 3, server 1, server 2, server 3, server 1, server 2, server 3. So you can see now it's going 1, 2, 3, 1, 2, 3, 1, 2, 3. So yes, this is what I want to achieve because we are using a round robin configuration. So basically, this is how you configure your NGINX to serve as a load balancer. Now, I'm going to show you in case you want to change the configuration. We are going to change the configuration now. Let me stop all of the servers. Let me stop all the servers. And let me do, let's do the one with this, with the least connection. Okay, so now how do you change the algorithm of your NGINX load balancer? Basically, you come to your upstream just before your server, where you write your server, you put list underscore con. So basically it changes this to list connection. If you want to use IP hash, so you do IP underscore hash. You understand? So that's basically how you do it. So let's change it to list con. So, and I don't expect it to behave the way it did when we were using round robin. So every other thing remains the same. We save, we do sudo nginx-t to check syntax is correct. So systemctl reload nginx, and then we are going to restart nginx. Okay, so now let's run our servers again. Server1.js, this is up and running. Server2.js is up and running, and then server3.js is also up and running. So let me open a new tab and do http://. So when I run this, it's response from server 1. When I reload from server 2, 3, 1, 2, 3, it's still behaving like this because there's actually no load on all of the servers. So it's still going to act like round robin because basically all of the servers don't have a load. So but imagine there is traffic. If there's traffic, coming in and all of that, it's going to route to the one that has the least connection. So basically that is how you configure NGINX to serve as a load balancer. So now we've added one more thing to it. We've considered NGINX and what it is about. We've served a static website. We're using NGINX. That's NGINX as a web server. We've used NGINX as a proxy server. We've also configured NGINX to act as a load balancer. So the last thing we are going to do for today is how to configure NGINX to use SSL certificate for responses. And now, what is SSL certificate? Basically, it enables encryption by using public key cryptography. Yes. So basically, what all these jargons means is that sometimes you would access, there's some website that you can access on HTTP and it will go through, and then there are some that you access using HTTPS. So basically, the S at the back is like adding, more security features basically. Yes. So we are going to configure NGINX to incorporate SSL to our website. So now we will not be able to access NGINX using HTTP. We will be able to access it using HTTPS. So we're going to quickly get that done now. And how do we do that? Um, let's stop all of our servers. Control C, Control C, and Control C. So basically, all we'll do is that we are going to, there are about two steps, basically, or maybe three steps to do it. So it's not something that is actually difficult. So first we make a directory where we want to store. Basically, it has to do with certificate, self-signed. You have a self-signed SSL certificate, which engineers will use to check for requests. Basically, in a production environment, you don't use self-signed certificate. There are certificate bodies that actually issues these certificates to organizations. That's why you can see you can access their website using HTTPS. So basically, we're going to generate our self-certificate by ourselves and then use it. So NGINX sat, no, I think I need to go back to my root. Okay, so cd into NGINX sat. So in here, we are going to type a command using, we are using OpenSSL to generate this certificate. If on the day one of this particular journey, when we were setting up our Ubuntu server, we ticked OpenSSL. So we ticked that. So it's already enabled. It's a command. OpenSSL is a command that actually helps us to generate this certificate. So it's similar to SSH key gen, where you have a private and a public key. Your private key remains on your system, while your public key is given to the general public for them to use to access files on your system. It's basically the same concept with this. We generate a private and a public key. Private key stays on your system. The public key is used to validate, any external persons trying to reach to your server. So we'll do OpenSSL x509. So this is a particular command requirement. So this node, what does it do? It tells OpenSSL not to encrypt the private key with a passphrase. So basically, we are not encrypting the private key. It's just there. So and then, how many days is this certificate going to last for? Let's say 365 days, which is basically 1 year, which is what most people use. So we need a new key, and the key type or the key format is RSA with 2048 bits. That's 248 bits long. So that's basically what it just means. RSA 248 bits long. So now we need where to, what do we name our private key? So key out, let's name our private key NGINX self-signed dot key. Don't forget the extension, it always ends with dot key. Your private key always ends with dot key. So this is the name we have given to our private key. And then -out. We're going to also name our public key. So we name it NGINX self signed dot crt. So basically, we are naming it nginx hyphen self sign, but the difference is the private key always ends with an extension of .key, while the public key always ends with an extension with .crt. Please take note of this. So the command is as simple as that: openSSL req x509 hyphen node hyphen days. It's supposed to be days. Supposed to be days 365 days. Then the nature of the key that you want to generate, which is RSA and is 2048 bits. Then you specify the name you want to give to your private key, name you want to give to your public key. It's as simple as that. So normally we are supposed to whatever we do here will be saved in this folder. So if you have another, say you're running this from your root folder now and you want to save it in a different place, you have to specify the path of where you want to save it. So but that's like stress on its own, and it's better for me to just create the folder and then run this command inside that folder so it saves in the folder. So when I press enter, it's going to ask for a question. Ignoring this, req unknown message node. Okay, nodes, supposed to be nodes. Okay, x509. Let me confirm this. Small letter x, not capital letter X. Usually I just copy and paste this command, but typing it by myself can have errors when you're doing all of this stuff. So basically it's generating the key. The first is to ask you for your country name. I'm in Nigeria, so I'll choose NG. To ask you for a state origin, I can leave that. My state, Lagos. I can actually, let's say organization, Vetrax, organization units, I can leave it. Common name, localhost. Please always use localhost as your common name for when you're making this, when you are doing this certificate. So after that, I can leave everything as empty. So we have our certificate created. So when I do ls, so you can see that I have both my private key and my public key. So if I can cut my public key because I can share that, but I can't share my private key. So this is how your public key would look like. So I can't share the private key, but this is how the public key is going to look like. So now that we have these two, what then do we do? We have to go back to our configuration and then make changes. So I'm going to vim slash. Before then, let me copy this pwd. Okay, nginx sat into ls. So nginx hyphen self signed. Okay, because I'll need to specify this part. So let me sudo vim slash etc slash nginx slash sites available slash default. Okay, so what am I doing here? So I'm just going to, for the sake of this, I'm going to delete all of this. Let me delete all of this. We'll go back to and use that our Node.js server that we used for the proxy. So let me change this to localhost 3000, which is what we used that other time. Localhost 3000. So yes, what I'm now going to do here, we are only going to make 3 changes. And what we are going to add here is we are going to add SSL underscore certificate. So certificate, and we're going to add SSL underscore certificate underscore key. So basically, this is where you paste the path to your public key, NGINX self-signed .crt, and then this is where you paste the path to your private key. So just change this to key, and then HTTPS does not run on port 80, it runs on port 443. So you have to change your port to 443, and then you specify it to use SSL. So basically, this is all that we are doing. We just added the part to our certificates, that's for the public and the private key, and then we changed our listening port to port 443. So let's every other thing remains the same. Let's confirm that we did what is right. Okay, we can see it through an error. It is not terminated by a colon. That is why it's always very, very good to run this command, because everybody is prone to mistakes. So what did I do? I should have ended this with a semicolon and with a semicolon. So that's sorted out. Let's run the command again. So you can see syntax is okay now. So sudo systemctl reload NGINX. So we reload our configuration and restart NGINX. So NGINX has been restarted. So we'll go back and we'll go to our, I think we used, yes, we used this node server. So node server ls. So when we do server node server.js, so when we run it, it's supposed to give us, okay, so it's running at localhost underscore 3000. So let's see if we can access it. So now we are not going to access it using HTTP. We are going to access it using HTTPS. So we'll do this and 192.168.199.136. So once I do that and I press enter, it's supposed to throw me yes. So once you see this, it means that what you're doing is actually working. Reason why we are getting this error is because it's a self-signed certificate. You can see it here, it's showing not secure. You can see it's not secure because it's a self-signed certificate. It is not gotten from the certified authorities. But if I click on advanced, it will tell me proceed. So when I click on it, then we have our backend server up and running. So basically, that is how you add SSL certificates into whatever you're doing. So let's see if we can access this same website on port 80. So 36. So once you do that, you will notice that we cannot access it on port 80. That's because the port is now on port 443. However, there's a way that we can ensure that whatever way you try to access this website, either you try to access this backend from using HTTP or HTTPS, it's going to work. How do we do that? Let's go back to our terminal. So let me stop this. We are still going to go and edit this. So what do we do here now? What we do is that we just create another server block, which port 80, and just tell it to refer to this server as the main server. So forward traffic, once you receive a request on port 88 or on port 80, forward the request to this particular server. So let's see how we're going to do it. We create a new server block, and we do the same thing basically. So we do listing on port 80, the server name is localhost, then the location is where we make changes. So we're just going to tell it to, what we'll come and do here is that we'll just tell it do a 301, return 301 https host request URI. So what did I do here? This 301 code basically means redirect. It's a redirection code. So if anybody tries to access this server on port 80, what it does is it doesn't do any other thing than to redirect the person's request to this particular block. So that's basically what it does. So let's test it and see if it's going to work. Fingers crossed. Let's check if our syntax is correct. Okay, syntax is correct. Let us reload. Let us restart NGINX. Okay, let us start our server. So our server is running on port 3000. So this is actually working right from time. So we know this is working. But now let us try it again. Let's try it. 36 at port 80. So when we click on this, it takes us, back to this. So we are accessing this using HTTPS. You can see it here. While we're accessing this, it has redirected it back to this particular place. So we are going to, it's just basically redirecting. It's just the same thing. It's just basically the same thing. So now anybody can reach my backend server either using HTTP or HTTPS. So now we've been able to cover NGINX. Basically, I think this is basically everything that you need to understand and be good at with NGINX as a DevOps engineer. You need to understand what NGINX is. You need to be able to set up NGINX as a web server, set up NGINX as a reverse proxy, as a proxy server. You need to be able to set up NGINX as a load balancer, and then you should be able to configure SSL certificates on NGINX. I really hope that by now you have a good knowledge of how to use NGINX. If you have any questions, any suggestions, you can drop them on the comment section, and I'll be glad to actually respond to them. And if you have anybody who has been struggling with NGINX or struggling with how to use NGINX, I would plead with you to send this video to them so that they can watch this video, and then their NGINX issues are going to be solved permanently. So this is the end of the first phase of our 100 days of DevOps. Tomorrow we'll be starting our second phase, which is I think second phase should be containers, and yes, we're going to start tomorrow, containers and CI/CD, and it's going to run from day 22 to day 42. So we are dedicating 20 days to actually learn containers and CI/CD, and I'm really excited to be doing this with you guys. Thank you all for the support so far, for the subscribers, for the comments, for the likes. I really appreciate, and I'll see you again tomorrow. Enjoy the rest of your day. Cheers.